Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 1 Learning Target 7. Today we are talking about graphing inequalities. So in Learning Target 6, we were working on graphing equations. We're going to start off with a little review of that and just refresh our memory. When we are graphing equations, the first thing that we want to do is make sure that the equation is in slope-intercept form. See that y is by itself, which in number 1 it is. Then the next thing we would do is look for the slope and the y-intercept. The y-intercept in this case is 5, and the slope is -3. That's our m, or our slope. So I start by graphing that y-intercept on my coordinate plane. My y-intercept is +5, which goes up 5 places from the 0, 0. And then my slope is -3, which is -3/1. So I go down 1, 2, 3, and right 1, and put a point. Down 1, 2, 3, right 1, put a point. Down 1, 2, 3, right 1, and put a point. You can do that several times so that you have enough points to make a nice, accurate, straight line across the coordinate plane. I mentioned yesterday how it was going to be really important for you to graph that line across the whole coordinate plane, and that's going to come into play today. We are going to need that line across the entire coordinate plane in order to graph our inequalities well. All right, let's take a look at number 2. In number 2, I have -x plus 3y is equal to 6. So I am going to add x to both sides because I need to get that y by itself. So I have 3y is equal to x plus 6. Those two things are not like terms, so I don't put them together. They're just kind of next to each other. Then the next thing I would do is divide by 3. Divide every term by 3. That makes that go away. That gives me 1/3 times x. And then 6/3 is 2. So I have y equals 1/3 x plus 2. I can go ahead and put this on the coordinate plane. This is going to be my y-intercept. I always put a dot above the line, sorry. And then this is going to be my slope. My slope is +1/3. So if I graph this on my coordinate plane, I'm going to go up to +2 and put a point. And then I'm going to go use my slope of 1/3, which is up 1 and over 1, 2, 3, and put a point. Up 1 over 1, 2, 3, put a point. We also talked yesterday about how you could go down and back. So I go down 1 and left 1, 2, 3, put a point. Down 1, left 1, 2, 3, put a point. And then I'm going to go ahead and draw a line through those all the way across my coordinate plane. Let's talk about an equation that doesn't have a y variable. An equation that doesn't have a y variable just looks like this, x equaling 5. What this means is that x is always equal to 5. So if I go out to where x is equal to 5 and put a point, my x value is always going to be 5. It doesn't matter where my y is. I could be up here at +6. I could be down here at -6. I could be at +4. My x value is always going to be 5. Y is not a factor here. So what happens is this ends up being a vertical line at x equaling 5. All right, so now let's talk about graphing inequalities. If I'm graphing inequalities, what I want to do is I want to put the inequality in slope-intercept form first. That's that y equals mx plus b. Solve for y just like we did all day yesterday. Then we want to decide what kind of line to make, and that's going to depend on our inequality symbol. We're also going to decide where to shade, and again, that depends on the inequality symbol. So we'll talk about the different inequality symbols and what kinds of lines and stuff we make to draw those, and where we shade to draw those graphs. And then graph the inequality using the y-intercept and the slope, just like we would with an equation. Okay, so let's take a look at number 4. So in number 4, I have y is less than or equal to 2x plus 3, okay? So again, the first thing that I want to check for is to make sure that y is by itself, which in this case it is. The inequality symbol is right here, okay? And y is the only thing on the left-hand side of it. Everything else is over on the right-hand side. So you could even make a little note to yourself and tell yourself that your y-intercept is 3, and your slope is 2. Okay, so y-intercept equals 3, slope is 2. Okay, now let's talk about this inequality symbol. Let me pick a different color here. All right, so the inequality symbol that I have is less than or equal to. That's how that reads, less than or equal to. Okay, this inequality symbol is an inclusive symbol. That means that I'm going to have a solid line because I'm including the values. That's what this tells me. This little piece underneath tells me that I'm going to have a solid line. And then I'm less than, so I want to shade underneath or shade below. Okay, so those are those two choices that I have to determine. So less than or equal to means that I'm using a solid line, but I'm shading below whatever the line is. All right, so now let's come back here and let's go ahead and graph our line. So I'm going to start by putting my y-intercept on the line just like I normally would. I'd come up to +3, graph a point. Then my slope is 2, so I'm going to go up 2 over 1 and put a point. Then down 2 and back 1 and put a point, down 2 and back 1, down 2 and back 1, down 2 and back 1. Okay, so now here's where I need to pay attention to these two choices. I know I want a solid line, so I am going to go ahead and connect these points with a solid line. Okay, great. Here's where it's really important that your line goes all the way across the coordinate plane, because the next thing you have to do is you have to shade underneath that line. Now, picture yourself being a little mountain climber. Let's say you're a little mountain climber and you're climbing up the mountain. Here you are. You're going to climb up the mountain, okay? If you were going to crawl down into a cave of that mountain, you would be down under here, okay? Those are the values that are underneath that line. Those are the things, that's where you're underneath the mountain. You have to think of shading below as being underneath. So if I'm shading below that line, that means I'm underneath my mountain. So my shading is this entire region underneath that line. And again, this is why it's really important for you to have a line spanning the entire coordinate plane, because you get a really nice picture when you shade the whole thing in. So every single value in that red region is a solution to this inequality. Every single one. Everything that you see that is shaded in red is a solution. Okay, let's take a look at number 5. So in number 5, again, I want to make sure that I have y by itself, which I do. My inequality symbol this time is that one. And over here I have 1x minus 6. So my y-intercept is -6 because of that guy right there. And my slope is equal to +1. All right, so now let's talk about the inequality symbol, okay? This inequality symbol is strictly greater than. If I was going to read that inequality out loud, I would say y is greater than x minus 6. Greater than x minus 6. So the two choices that I make for that, number 1, I need a dotted line this time. I am not including the values on the line. The line is just going to be my boundary marker. It doesn't include the values that are on the line in my solution set. And then because I'm looking for values greater than, I want to shade up. I'm going to shade above the mountain this time, just like I'm shading up into this, jumping up into the air, jumping up into the sky. All right, so let's take a look at our graph. I'm going to go ahead and graph that graph here. I want this purple. Here we go. So I have a y-intercept of -6. And then my slope is +1. So I go up 1 and right 1, up 1, right 1, up 1 over 1, up 1 over 1, and I can keep going all the way across. Remember, the more points you put on your coordinate plane, the more accurate it is. Okay, remember, you want a dotted line here, not a solid. If you already drew a solid line, you're going to have to go back and erase. You want a dotted line. Some people call it dashed. I don't know, I call it dotted, but I usually end up drawing dashes. Sorry if that doesn't make sense. It doesn't matter. You basically need to leave space between some of your markings there, okay? Now, again, here's my little mountain climber. Where's my mountain climber? Let's get him back. So our mountain climber, he's standing on the mountain. Okay, here he is, super happy, climbing up the mountain. He wants to jump up in the air. We're gonna shade up. That means he is jumping up into the air. Values that are above the line are up as if the mountain climber is jumping up into the air. So I am shading above the line here, all the way across my coordinate plane. And that whole purple region, which is like almost the entire coordinate plane, that whole purple region is solutions to this inequality. Okay, so anything that is greater than x minus 6 is in that purple region. All right, next one. I have y is greater than or equal to negative 4x plus 2. Okay, so once again, I see that y is by itself. Here's my y-intercept. Here's my slope. Okay, the inequality symbol is this guy. Now I'm looking at greater than or equal to. Y is greater than or equal to negative 4x plus 2. So this is greater than or equal to. So one little trick that I use to remember the kind of line, the fact that there's this solid line underneath my inequality symbol tells me that I'm going to have a solid line graphed here. That's one of the choices that I have to make. So I have a solid line. Then the other thing that I have to decide is the direction I shade. And I'm looking at values greater than, which means I'm going to shade up. So again, my little mountain climber is going to jump up into the air. All right, so let's put it on the coordinate plane. So I've got a y-intercept of positive 2. I'm going to start there. I have a slope of negative 4. So I'm going to go down 1, 2, 3, 4, and over 1. Down 1, 2, 3, 4, and over 1. You can also go up 1, 2, 3, 4, and back 1. All right, solid line. So my dots get connected. They're all connected with a line. Sorry, my line got a little messy up there at the top. So I have a solid line. Now, the steeper your line is, the harder to determine where it is to shade, because shading up is not super easy to figure out when your line is almost vertical. It's like there is no up or down. Oh, I did not draw my stick figure very well. Let's try that again. Let's give him a body instead of just legs. Haha. Okay, so here's my mountain climber. He's going up the mountain. If he jumps up into the air, he's in that region. He's not climbing down into a cave. He's jumping up into the air. So we are over here. This is his shading up. If you have a hard time figuring out which direction to shade, the other thing that you can do is plug a point in. Pick a test point. Let's say I want to test 0, 0. If I plug in 0, 0 into this equation, I'd have 0 is greater than or equal to negative 4 times 0 plus 2. Okay, that's plugging in 0 for x and 0 for y. I end up with 0 is greater than or equal to 0 plus 2, which gives me 0 is greater than or equal to 2. Now, is 0 greater than 2? No, it's not. 0 is not greater than 2. This is not true. So that means that the 0, 0 is on the wrong side of the line from my shaded solutions. So that's just another way of seeing like, oh, yep, I need to shade the other side. So you can always pick a test point. I usually like to pick 0, 0 if I can, because I think that's just easiest to work with. Or 1, 1. Some people like to use 1, 1 because that's an easy one to do too. And then that, if it's true, if you get a true thing, then that's where you shade. If you don't get a true statement, then you need to shade the other side of the line. Okay, let's try the next one. I've got y is greater than 1/2 x minus 2. Here's my y-intercept is equal to negative 2. Here's my slope, positive 1/2. Here's my inequality symbol, greater than. Okay, my inequality symbol is greater than. So that means I'm looking at a dotted line or dashed, if you want to call it dashed, doesn't matter. Either way works. And I'm greater than, so I'm jumping up into the air. So this is a dashed line, and then I'm shading up. Okay. So I have a y-intercept of negative 2. Here's my negative 2. Then I go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 and back 2, down 1 and back 2, and that gives me enough points. So if I could go do one more. There we go. If I put in my dashed line here, sorry, I hit the wrong button, so it turned on a new menu. There we go. There's my dashed line. Your mountain's pretty flat this time. It's just like kind of a shallow hill. So shading above is usually a lot easier to tell when your line is not as steep. So above the line is up here, and everything in that purple shaded region is a solution. So again, when your line is dashed like that, it's just a boundary line. It's just a marker of where the solution set stops. The values that are on that actual line are not solutions. They're just marking the end of your solution set that was above it. Okay, next one. Now we have some work to do at the beginning. We need to make sure that we put this equation in slope-intercept form first. So I need to get this y by itself. I'm going to start by subtracting 3x from both sides. So that goes away. I have negative 2y is greater than negative 3x minus 6. Then the next thing I would do is divide both sides by negative 2. Every term gets divided by negative 2. If you think back to inequalities that we worked with at the beginning of this unit, I'm dividing by a negative here. Dividing by a negative means my sign is going to flip. So when I do that, negative 2 over negative 2 goes away. I have y by itself, which is what I want. Negative 3 divided by negative 2 is just positive 3/2. I'm not going to turn it into a decimal. I don't want it to be a decimal. I like it being a fraction. It's a lot easier to graph that way. Then negative 6 divided by negative 2 is positive 3. So now I know that my y-intercept is equal to 3 and my slope is 3/2. That inequality symbol that I'm working with now is this one. So I'm looking at less than. That means I have a dotted line, and I'm shading down. I'm less than, so I'm underneath the line this time. Okay, so let's go ahead and put it on the coordinate plane. Here's my equation, just in case you lost it. That's the one I'm working with. So this whole thing right here turned into that in slope-intercept form. So I start with my y-intercept of positive 3, and then my slope is 3/2. So up 1, 2, 3 over 2, or down 1, 2, 3 back 2, down 1, 2, 3 back 2, down 1, 2, 3 back 2. And look, I'm in the very, very corner. Oops, I switched colors on accident. Very, very corner there. Okay, so now I'm going to fill in my dotted line there, or dashed, again, whatever you want to call it, dashed, dotted, same thing. And then I want to shade below. So if you're the little mountain climber, here's my mountain climber. He's up here. He's happy and climbing up the mountain, and he's going to jump down into a cave. If he shades, or if he goes underneath the line or underneath the mountain, he's down in a little cave there. So my solutions are underneath that line. That's where less than would go. Down here underneath. Everything in the purple is a solution set. My line, my inequality line, is just a boundary line. The values on the line don't count, but everything that's shaded in purple is a solution. Next one, 5x plus y is less than or equal to 10. So again, y is not alone right now. I need to get rid of the 5x. I need to get rid of the 5x, and I end up with y is less than or equal to negative 5x plus 10. So my y-intercept is 10, and my slope is negative 5. My inequality symbol is still less than or equal to. I didn't divide by any negatives, so I don't have to flip that. So that's less than or equal to. Okay, that means I am going to have a solid line because I am including the values, and I'm going to shade below because I want values that are less than the line. Solid line and shade below. All right, so The first thing that I want to do is graph my y-intercept of positive 10. Now, you're probably thinking, Johnson, the positive 10 is off the coordinate plane. That's not helpful. So if I look at this 6 and I try to kind of guess where my 10 is, it's probably, that would be about 7, that's about 8, that's about 9, that's about 10. It's probably way up here somewhere. But the thing is, once you come down 5 and over 1, I'm back on the coordinate plane now. So I came down 5 places to where the 5 is and over 1. Now I'm going to come down 5 more places to the 0 and over 1. Go down 5 more places to the -5 and over 1. This is a really steep line. It's a solid line, so I'm going to fill it in with a solid line here. It's really steep. And we talked about how when lines are really steep, it's hard to figure out what's above or below. The things that are underneath this line, again, picture this being like a mountain. If that were a mountain, where would the caves be? Where would you be if you jumped down into a cave? That's where you are when you're shading less than. So there's my mountain, and that blue region underneath are the solutions that are less than. Number 10, I have y plus 3x is greater than or equal to -6. So I'm trying to get y by itself. I'm going to subtract the 3x, and I end up with y is greater than or equal to -3x minus 6. So my inequality symbol is greater than or equal to and that means I have a solid line, and I'm shading up because I want values above it. I'm including the values on the line. That's where I get the or equal to part, and I'm shading up from the greater than part. Okay. So -6 is my y-intercept. Now, again, this is another one where your coordinate plane is limited. So if I wanted a slope of -3, that means I would go down 3 places and right 1. That's really hard to graph because it's off my coordinate plane already. So I'm going to go up and back instead. So I'm going to go up 3 and left 1. Up 3 and left 1. And I can keep going. Up 3 and left 1. One more time, up 3 and left 1. So all of those points make my line. And I go all the way across the coordinate plane, and now I'm shading up. So if I'm the mountain climber on the line, whoop, I'm jumping up into the air, which means I'm out in this region. And again, if you want to test a point, go ahead and plug in 0, 0. If I plugged in 0, 0 here, let's see what happens. I'd have 0 is greater than or equal to -3 times 0 minus 6. -3 times 0 goes away. That 0 is greater than or equal to -6, and that is true. So my 0, 0 right here should be in the purple region, and it is. So my test point worked, so I shade in that direction. Last one that we're going to talk about today, number 11. So what I need to do here to get the y by itself is divide by -2. Everything gets divided by -2, and I'm dividing by a negative, so my inequality symbol is now going to be greater than. I have y is greater than -2x plus 5. 4 divided by -2 is -2. -10 divided by -2 is positive 5. So here's my y-intercept. Here's my slope. Y-intercept is 5, slope is -2. My symbol is greater than. You always want to make those choices after you solve the equation for y, because your symbol may flip. In all of your solving for y, your symbol may have to do some flipping, so then it might actually change. Like ours started as a less than, but we had to flip it, so now it's a greater than. So this is a dotted line, and I'm shading above. Shade up. All right, so positive 5 is my y-intercept. Here I am. -2 is my slope. That's down 2 over 1, down 2 over 1, down 2 over 1, and so on and so forth. And I want a dotted line there. And I'm shading above which is this direction. All right. All right, that takes us to the end of our notes today. This is your last notes for Unit 1. Woohoo! Thanks for listening, and if you have any questions, let me know, and I will catch you next time.